Okay, so just a quick question here on looking at combining matrix transformations. And remember the rule that we saw previously, which said this: if we apply a matrix, if we apply a matrix A followed by matrix B to a point, the combined transformation is BA. So basically, you switch the order and you multiply them, and we saw that on the previous video. Now this question says the unit square is transformed by the matrix 0, minus 1, 1, 0. I'm just going to go and call this the matrix transformation A, just to make it clear what is going on, followed by a further transformation. That's going to call it transformation B, which is this over here, 1, 0, 0, minus 1. And to be honest, you don't even need to know in this case what the transformation that these matrices provide are. Okay, you're just given them. It says work out the matrix for the combined transformation, so times them and flip them, and then describe it geometrically. Let's do the first bit first of all. Okay, so work out the matrix. So up here we're saying we times them, we flip the order around. So we do B times A, and B is the matrix 1, 0, 0, negative 1, and we times it by matrix A, which is 0, minus 1, 1, and 0. And we're just timesing here our 2 by 2 matrices, which I'm assuming that we're pretty well versed at now. Okay, but we'll go through it. So that's going to give us a 2 by 2. And we times the rows with the columns. So we do 1 times 0 is 0, add 0 times 1, which is 0. So your first number is 0. First row with the second column, 1 times by negative 1 is minus 1, and 0 times by 0 is 0. Add them, we just are left with negative 1. We then go on to our second row with the first column. 0 times 0 is 0. Negative 1 times by 1, again, is negative 1. We then do our second row with our second column. 0 times by negative 1 is 0. Negative 1 times by 0 is 0. 0 plus 0 gives you 0. So that's going to go down to here. So this is the first part. You've worked out the matrix of the combined transformations. We just flip the order and we times them. So this is the answer to part 1. There we go. But it now says to describe this geometrically. Now, if you've memorized your matrix transformations, that's going to be pretty useful here because you can just go and say what this is. Now, I'm going to assume, right, you're in the exam, you've forgotten what it is, and we want to derive it and prove it for ourselves, which is always a good thing to do. Okay, so how do I work out again what transformation this matrix produces? Now, we saw previously on a previous video, we can always go back to our unit square over here and just go and put in the points. 1 up here, 1, 1, 1 across, 1 up. There we go. That should be a unit square, okay? Now, we need to consider our identity matrix, okay, which again is, identity matrix is given by 1, 0, 0, 1, okay? And where this is your x coordinate, x, and this down here is the y coordinate. Same thing over here. This is x and this is y. And you want to see, right, how these points here, 1, 0, remember that's a coordinate, and 0, 1, how they're going to change. Now, so if I look at the point 1, 0 over here, well, 1, 0 is the point over here. There we go. And then 0, 1 is going to be going over up to here. Okay, there we go. Now, actually, we can see that this has gone to the matrix up here that we want, which is 0, minus 1, minus 1, 0. Okay, I'm going to go and do those points in green. So 0, minus 1 is down here, 0, negative 1 is down here. And then we've also got minus 1, 0, minus 1, 0, which is over here. Okay, so we've got this instance over here. Now, you've got to be a little bit careful here because here it could be either a reflection in y equals to minus x or a rotation 180 degrees. So you've got to be a little bit crafty here. If I look at the point 1, 0, which is over here, this blue point here, I'll just colour it in green again. Well, this point 1, 0 has gone to 0, minus 1. You've got to look at the first two here and the first two over here. So it's gone from 1, 0 to 0, minus 1 to down here. So it's gone across over here. Now this is a reflection. If you rotated this by 180, this point would not go down here. You could prove it by tracing it over and going through it, but it wouldn't work. So I know it's going to be a reflection. I'm just going to double check it. If I look at this point, 0, 1, okay, get rid of that, 0, 1, that's gone to minus 1, 0. 0, 1 is here, minus 1, 0 is here, it's gone over here. Now this must be described by a reflection in the line y is equal to minus x. Okay, so the transformation is let's go and write down here, it's going to be a reflection, that's 1 mark, in the line y is equal to negative x. You've got to be careful because it could look like it's a rotation by 180, but it isn't, okay? Because again, just to make it really clear, hopefully, right, if you rotated this point by 180, this point here, okay, that would be 90, 180 would be over here, and it doesn't correspond to the point over here that you want. So that's how you can check it. Now, you can see there, even though deriving it is good, it could be quite time consuming. So if you can memorize your transformations, that's going to be a useful thing to do. But anyway, there we go. That was hopefully detailed for you guys. So the first part, the matrix, was your answer. And the second part, describing it geometrically, was the part